and welcome back to my channel. Today we're going to take another tour of Eaton Canyon Natural Area, this LA County park in the Pasadena-Altadena area on the foothills of the San Gabriel Mountains, also so known as the Angeles National Forest. So the San Gabriels are the mountains, the Angeles National Forest is of course the federally managed public land that covers the entire mountains. Today we're going to be focusing a little bit more on the geology of Eaton Canyon, which is also meant to be a little bit more representative of a lot of the areas along the foothills. We're going to talk about some of the common rock types, start off with some of the common rock types. Then we're going to talk a little bit about the forces of erosion, transport, deposition of sediment, okay, that shapes the canyons and this accumulation of river gravel that you can see here, as well as mass wasting. We're going to take a look at a couple places where there has been some small landslides. So first off, I'm standing on this gravel bed here. This is all basically sand and gravel, and even though a lot of these are pretty large, these boulders, they are still classified as gravel. Okay, anything that is essentially over 2 millimeters in diameter is technically gravel according to geologists and earth scientists. So a few things, of course, the stream is still flowing, as you can see here. It's flowing downhill, so again, most years it is not flowing by April. Okay, we had a very wet winter. We're past the wet season, but it is still flowing pretty strongly here. So one thing about a lot of the gravel and cobbles and boulders you find along a riverbed is the fact that it's fairly rounded. Okay, so you can see here this is fairly rounded. Most gravel is along the stream bed, again, is a little bit more smooth, rounded. You don't really find too many rocks here with a lot of corners and edges. Why is that? I'll give you a second to think about it. If you were to look at the base of a cliff, such as along a mountain road, for example, you probably would see a lot of rock fragments with a lot of corners and edges as a product of rockfall. However, here on a riverbed, rocks basically, as they've been transported from the mountains, as they've weathered out of the mountains, and running water would carry them, all these rock fragments, all the corners and edges would basically get polished away, chipped away, smoothed, and by the time it actually gets deposited along a gravel bar or gravel stream bed, as you see here, the corners and edges have largely been polished away. So the more smooth and rounded rock fragment is, the longer it's been transported. It's gone under the process of the stream transporting it. Okay. Now over at this point, the stream is not very powerful to really carry many big rock fragments. But at the time, back in January and February, when we were getting a lot of heavy rain, it certainly was powerful enough to push gravel along the bed of the stream. So it does it little by little, okay? It may take a long time, but again, it does get transported little by little. Now the rock fragments that you see here are entirely igneous and metamorphic, okay? There are no sedimentary rocks in the San Gabriel Mountains here at all. A lot of our lower hills, our lower ranges of hills in Southern California certainly do have a lot of shale and sandstone. But these mountains here, those sedimentary rock layers were eroded away hundreds of thousands of years ago. Okay. Now, what are these kinds of rocks? Well, again, these are all mostly igneous and some metamorphic. Rising magma. During the Mesozoic era, basically the time of the dinosaurs, you had magma rising through the earth and then cooling. Okay, so you get a lot of formation of these rocks that are kind of related to granite, similar to granite, but are a little different. And that includes a couple kinds of, again, similar rocks like this granodiorite, and this is called Mount Low granodiorite, and this is called Mount Wilson diorite. So what's the difference between granite and diorite? Well, what they have in common is that they're both intrusive or plutonic igneous rocks. They have a lot of large mineral crystals because since they cooled below the Earth's surface, closer to the heat of the mantle, they cooled a lot more slowly, which allows larger mineral crystals to get bigger. But diorite has a lot more iron and magnesium based minerals, whereas granite typically does not. Granite has a lot of minerals like quartz, which the diorite does not. Basically, you get a lot of this diorite in places where you have both continental and ocean crust magma basically kind of mixing. So they call this like intermediate igneous rocks. Now I want to point out a couple things. I want to point out this high ground here that is, you can kind of see off over here, that is clearly marked by the yellow wildflowers. That's basically a chaparral sunflower. It's in the Encelia genus of flowers. You typically find it a little bit more closer to the coast, but here they are at Eaton Canyon. And that elevated land surface there is what they call a river terrace or an alluvial terrace. That was the top edge of where those flowers are, was the high point of the of where the river floodplain was at one time. But as the mountains lifted, they lifted all the flatlands of the valley here, or the basin, lifted it higher, and so the stream started to cut down into its own floodplain. And then over time, the stream would shift laterally or side by side, essentially widening and creating a new valley within its older valley. Okay, so you can see these river terraces are quite common. This one is, you know, maybe about 30 feet higher above the bed here. And we're going to look at another terrace, a much higher one, where many houses in the adjacent neighborhoods are set upon. Okay, so we're going to be going a little bit more upstream and taking a look at some other landforms that are a product of deposition, erosion, and mass wasting. So with that, I will see you soon, and signing off. And here we are at an ideal place to see 3 different flat land surfaces that represent 3 different periods of when Eaton Canyon Wash was depositing sediment, depositing alluvium. So I'm standing on right now is the same land surface level as in the first video. It's the modern floodplain where you have a lot of big gravels and boulders deposited by the river in relatively recent Earth history. Okay, but this upper level where you can see a couple hikers walking on, represented by the upper level of where you can see all these sunflowers. It's a perfect time of the year to see this because you can really see all these chaparral sunflower or Encelia plants growing on the first terrace above the modern floodplain. Terraces have long been a very ideal, desirable place for civilization, for towns and villages. Basically having access to the river or the creek and the fresh water it provided, the transportation it provided, you know, for small boats, but yet nonetheless though it was flat, and oftentimes the soil fertility was still very good for as river deposited sediment usually is. But anyway, but it's also above more or less above the flood stage. Now you can see the highest terrace off in the distance, which is, I don't really exactly know, but it's a couple 100,000 years old probably, when the river was actually at that level. But you can see where the houses are, okay? Houses over here would not be a good idea because of the flooding. That's why it's ideally suited as a park. But you can see the highest terrace up there, and on the side of it you can certainly see a lot of same kind of sediments, you know, again, rounded boulders that were deposited by the river. So wherever you see rounded, smoothed boulders, you know that to be deposited by a river as opposed to just have accumulated at the base of a cliff from rockfall, or what we call talus. So anyway, so we have one land surface, the second terrace, the first terrace above the floodplain where all the sunflowers are, and then the highest terrace above that where you see those houses up on the bluff. Okay, so now we're going to take a look at some evidence of landslides, and then we're going to finish off at the point where the mountains really begin and the canyon really begins. So with that, I'll see you then. And here we are. This is the Mount Wilson Toll Road, as it's called. It's a trail that goes up to a place called Henninger Flats, which is like a campground at the very end of the road. But we're basically overlooking here the creek bed of Eaton Canyon Wash. There's riparian forest here. There's sycamores growing and alders and coast live oak. But and you can also see just a little bit, there is a bridge right over there. And a lot of hikers today, even though this is a weekday, I think because it's spring break maybe, there's a lot of people here, and you could certainly hear them down there going back and forth with their kids. But that is the direction to the waterfall. But this is a great place to point out because right where the bridge is essentially the border between the broader Eaton Canyon Wash and where you really get into the canyon itself. We're really right here on the very edge of the mountains. So the character changes drastically from a broad wash with bluffs and terraces on both sides to very steep rocky mountains with a very narrow rocky canyon that goes further into the mountains. And so and this is really significant because this is the point where there's an underground fault. Okay, so we're right pretty much on a fault as we speak. We're actually really right where the bridge is. And it's actually what they call a reverse fault. There's a reverse fault called the Sierra Madre Fault that runs along the south edge of the San Gabriel Mountains. And so there's been uplift, kind of a little bit like this, of product of compression, where the mountains were basically forced up like this, and over time rockfall and mass wasting and erosion would smooth out any kind of overhangs. But this is basically why you see very, very steep mountainsides, is that it's a fault that has moved along a compressional force, which has basically uplifted the mountains little by little over time. Now these mountains have also been shaped by an actual rotating of the mountains. When you look at a map, most of the mountain ranges, like the Sierra Nevada, like the coast ranges, like the peninsular ranges, that includes the San Jacinto Mountains that are an extension of Baja California, they all tend to be on a north-south trending orientation. But the San Gabriel Mountains are part of the transverse mountain ranges of Southern California, where basically there's been a big bend in the Sierra San Andreas Fault, and so over time the mountain ranges have kind of rotated. That has caused a lot of tension on the rocks, and so they tend to be highly weathered. There's not too much rock here that is really safe for rock climbing at all. So it's very crumbly, very weathered, and a lot of the rock has been very contorted and so forth. I want to point out a couple interesting things here. So you'll see a lot of pink mineral grains like this over here. This is a feldspar. It's actually kind of what's called an orthoclase feldspar. So like any kind of pinkish minerals that make up some of the rocks you find here, that is a feldspar. So it's one of the common silicon-based minerals that you'll find. This isn't necessarily the perfect example, but if you look at this carefully, you can maybe see just a little touch of green. This is a common mineral that you'll find here, a dull green mineral called epidote. Epidote, E-P-I-D-O-T-E. It's kind of interesting. It does kind of stand out a little bit. It might look a little bit like lichen, that kind of green, crusty hybrid between algae and fungus that breaks down rock that you see all over. But it's actually a mineral that is this kind of a dull green. Okay, so anyway, where you see the bridge really basically more or less marks the fault, and it goes from a broader valley to a very narrow canyon, and it's that direction to the waterfall itself where everyone is going. So we're going to make one more stop and look at the impact of a landslide to talk about mass wasting and how the sides of the canyons and valleys shape over time. So with that, I'll see you then. Okay, we're going to make one last stop here along the trail. This might be a little bit hard to really see and the whole thing, but basically what where we are here is that this is an area of landsliding along the main trail in Eaton Canyon. What you can see to my left here, it looks a little bit more barren of vegetation. That's basically where you're seeing a lot of consistent bits of rock fall on a steep slope. A slope that is at least as steep as what they call the angle of repose, which is an angle of steepness that is minimally necessary to where you can actually have landslides or other mass wasting being triggered. To my right, you see a little bit more vegetation. Okay, a lot of California sagebrush. Okay, so one of our main plants of our coastal sage scrub. So what you've been seeing here is that because of this very steep slope, you've had consistent rockfall, and soil really has not gotten a good chance to really develop. Plants haven't really had the opportunity to get rooted, and a lot of that crumbling rock that slowly accumulates is basically accumulating at the toe or the foot of this landslide here. And so it's a little bit more finer bits of sediment, and so you have a little bit more of an accumulation of soil developing that allows some of these plants to take root. So that's one of the key things to look for if you're looking for an area where there's been evidence of landsliding, is that do you see a steeper area where it looks very bare, okay, where you see a lot of bare rock, bare sediments, and then an area at the base of that slope where it looks like there's been a lot of accumulation of vegetation. It's a helicopter flying overhead. So that was a sheriff's helicopter. There might be some kind of search and rescue effort going on. So anyway, that finishes up and wraps up our tour, geologic tour of Eaton Canyon Park natural area. So we started a course at the most downstream portion of the stream, looking at the gravel, looking at terraces. We moved on to look at the point where the mountains really begin, where the fault is, and we ended at this place where we can see the evidence of a landslide. So with that, I hope you enjoyed that today, and don't forget to like, share, and subscribe, and I'll see you next time.